All right. Welcome back, deep divers. Ready to jump into another fascinating topic?
Always ready to dive in.
Today, we're going deep on something that sounds pretty complex, maybe even a little intimidating. Kalman filters.
Yeah, I can see how the name itself might not exactly scream, everyday relevance.
Right. But trust me on this one, folks. These things are quietly running a huge chunk of our modern world, even if we don't realize it.
It's true, Kalman filters are working behind the scenes in so many technologies we take for granted.
So before we get into the nitty-gritty, can you give us the elevator pitch? What is a Kalman filter in simple terms?
Well, imagine you're trying to track something that's constantly changing and moving.
Okay, like a bird flying through a forest.
Perfect example. Now imagine you only get glimpses of that bird every now and then through the trees and leaves.
So you're dealing with like incomplete information and a lot of guesswork.
Exactly. And that's where Kalman filters come in. They're algorithms that help us estimate the state of a system, like the position of that bird, even when our measurements are noisy or incomplete.
So it's kind of like a super powered guessing game, but with like math and algorithms instead of intuition.
You could say that. It's about making the best possible guess based on all the information we have, even if that information is limited or unreliable.
Okay, I'm intrigued, but my brain is already starting to hurt a little. Can we break down how it actually works?
Absolutely. So, at its core, a Kalman filter uses a two-step process: prediction and update.
Okay, so first it tries to predict where our bird is going to be.
Exactly. And that prediction is based on what we call a model of the system. In the case of our bird, the model might include things like its typical flight patterns, its speed, and maybe even how wind conditions might affect its movement.
So it's using its knowledge of like bird physics to make an educated guess.
Right. But it also knows that its prediction isn't going to be perfect, so it factors in a certain amount of uncertainty.
Which makes sense because, birds can be pretty unpredictable.
For sure. And that's where the update step comes in. When we get a new measurement of the bird's position, maybe a brief visual sighting, the filter compares that measurement to its prediction.
And I'm guessing if the measurement is different from the prediction, the filter has to adjust its thinking.
Exactly. And this is where it gets really clever. It doesn't just blindly accept the new measurement, it weighs both the prediction and the measurement, taking into account the uncertainty associated with each.
So if the measurement seems more reliable, it gives it more weight.
Exactly. And based on that weighting, it updates its estimate of the bird's position, making it more accurate.
That's amazing. So it's this constant back and forth, predicting and updating, always refining its understanding of where the bird is.
Precisely. And it's this iterative process that makes Kalman filters so powerful.
Okay, so I get the bird analogy, but I got to ask, where does this play out in the real world, beyond birds in a forest?
Oh, it's everywhere. One of the most common examples is GPS navigation.
Hold on, you're telling me Kalman filters are the reason my phone can tell me how to get to the grocery store?
Yep, they're a key part of what makes GPS so accurate. Think about it. The GPS signals from satellites can get disrupted by all sorts of things: buildings, trees, bad weather.
Oh yeah, I've definitely had my GPS freak out on me in certain areas.
Right. But the Kalman filter running in your phone, it takes those sometimes wonky GPS signals and combines them with its knowledge of how cars move, like how fast they can accelerate, turn, things like that.
And that helps it like smooth out the errors and keep my blue dot on the map from, jumping into a lake.
Precisely. It's constantly adjusting and recalibrating based on the new information it's getting.
That is so cool. Okay, so GPS, what else? You mentioned earlier they're used in like self-driving cars.
Absolutely. In fact, Kalman filters are essential for self-driving cars to, well, not drive into things.
Right, stakes are a bit higher there than just missing a turn on the way to the store.
Exactly. Self-driving systems are using sensors to constantly scan their surroundings, but sensor data can be messy and inconsistent.
So the filter helps make sense of all that sensory input.
Exactly. It takes in data from cameras, radar, LiDAR, all of it, and uses it to estimate the position and movement of everything around the car: other cars, pedestrians, obstacles.
And that allows the car to make safe decisions, like when to brake, when to change lanes.
Right. Without Kalman filters, self-driving cars would be constantly jerking around, overreacting to every little blip in the sensor data.
I mean, I do that sometimes even with Kalman filters helping me out.
Well, we all have our moments.
How about it?
But seriously, it's the filter that helps create that smooth, safe driving experience that self-driving systems are aiming for.
So we've got navigation, self-driving cars, What else?
Oh, there's so much more. Like, how about missile guidance systems?
Okay, now we're talking serious stuff.
Yeah, Kalman filters play a critical role in ensuring those missiles hit their targets accurately.
Wait, so these filters are literally helping guide missiles in flight?
Absolutely. The filter has to take into account not only the missile's own trajectory, but also the movements of the target, which might be moving unpredictably.
And it has to do all this in real time.
Real time and with incredibly high accuracy.
Yeah.
It's constantly making adjustments based on sensor data and its model of how the missile and the target are behaving.
That's mind-blowing. And it makes sense, I guess, if you want to hit a moving target, you need something that can predict where it's going to be.
Precisely. And Kalman filters are ideal for that kind of prediction problem.
Okay, so we've got missile guidance, but you said there are a ton of other applications too, right?
Oh, yeah, tons. Like, they're used in robotics to help robots understand their environment and navigate effectively.
So like a Roomba wouldn't bump into my furniture quite so much with a good Kalman filter.
Exactly. It helps the robot map its surroundings and avoid obstacles. And then you have things like object tracking in videos, which is used in everything from security cameras to sports analysis.
So like when you see those yellow lines tracking players on a football field,
That's it. Kalman filter is helping us understand the movement of those players. And they're even used in things like economic forecasting, trying to predict how financial markets will behave.
so basically anywhere you need to make sense of messy real-world data, Kalman filters can help.
That's a great way to put it.
This is blowing my mind. It's like this hidden hand that's making all of our technology smarter and more reliable.
I know, right? It's one of those things that once you start seeing it, you realize it's everywhere.
Okay, before we get too lost in the weeds, let's recap the key takeaways here.
Good idea.
So, Kalman filters. They're these incredibly powerful algorithms that take in tons of information, filter out the noise, and give us the best possible estimate of what's really going on.
And they're not just making our GPS work, they're enabling self-driving cars, guiding missiles, helping robots see, even predicting the stock market.
It's really remarkable how one algorithm can have such a profound impact on so many different fields.
It is, and it all comes down to this elegant interplay of prediction and update, constantly refining its understanding of the world around it.
And here's the thing that really gets me. We've talked about all the amazing things Kalman filters are doing now. But what about the future?
Oh, the possibilities are endless.
As this technology gets even more sophisticated, what new problems will it help us solve? What amazing new innovations will it enable? It's exciting to think about.
It really is. And it just goes to show sometimes the most impactful technologies are the ones working quietly behind the scenes.
So deep divers, keep that in mind as you go about your day. Look around, pay attention. You might be surprised at how often this hidden hand of Kalman filters shows up in your life.
You never know where you'll find them next.
And until next time, happy filtering.